Hello and welcome back. In the previous video, we looked at the different modes in which Hadoop can be set up. In this video, we will see how to set up a single node Hadoop cluster on the virtual machine you have downloaded. To set up Hadoop in pseudo-distributed mode, we need to edit a few configuration files. Firstly, we need to edit the hadoop-env.sh file. This file contains some environment variable settings used by Hadoop. You can use these to control some aspects of the Hadoop daemon behavior, such as where log files are stored, the maximum amount of heap used, etc. For our class though, the only variable you should need to change in this file is java_home, which basically specifies the path to the Java installation to be used by Hadoop. You already know the path of your Java installation since you updated the bashrc file previously. You can copy the same and edit this file as well. So let us navigate to the conf folder inside Hadoop and then edit the hadoop-env.sh file. So let's use vi hadoop-env.sh. So you have to update the java_home path to where you installed Java, which I have already done, right? But be sure to not include the /bin in the path. Let's exit. So one of the basic tasks involved in setting up a Hadoop cluster is determining where the several Hadoop related directories will be located. Where they go is up to you. In some cases, the default locations are inadvisable and should be changed. This needs to be configured in the core-site.xml file, which also contains other configuration information such as the default name of the file system. So to do this, let us edit the core-site.xml. So here you need to update the fs.default.name and the hadoop.tmp.directory properties, right? So what we are doing here is that we are setting the name of the file system to be hdfs:// the port number, which is 54310. In fact, it is always better to use the actual host name instead of localhost, but for now this setting will work just fine. And we are also setting the hadoop.tmp.dir property to be /tmp/hadoop. So let's save and close. Now let me give you a bit more information on hadoop.tmp.dir. So basically, Hadoop has to store your HDFS blocks or store some temporary data while running your MapReduce jobs, right? Hadoop needs to know the path in order to do this. In the core-site.xml, you can configure the hadoop.tmp.dir property with a path, and by default, this path will be used as the base for other directories. Now let's say, like we have done, let's say you configure hadoop.tmp.dir to /tmp/hadoop. There are 3 HDFS properties configured in other configuration files which use hadoop.tmp.dir in their default values. The first one among them is dfs.name.dir. This determines where on the local file system the name node stores its metadata, that is the fs image file, and its default value is basically hadoop.tmp.dir /dfs/name. So essentially this property is now set to /tmp/hadoop/dfs/name. And similarly you have dfs.data.dir. This determines where on the local file system a data node should store its blocks, and you can see the default value also contains hadoop.temp.dir. And finally you have fs.checkpoint.dir. This is the directory where the secondary name node stores its checkpoints, and the default value again contains hadoop.tmp.dir. So as you can see, hadoop.temp.dir is a base for other directories by default. So it is very important that in a real production cluster, the dfs.name.dir and the data.dir properties be moved out from hadoop.temp.dir, because a production cluster should never consider these directories as temporary, as they are where all the persistent HDFS data resides. So a better way to configure would be either to not use hadoop.temp.dir in other property values at all, or at least ensure that this hadoop.tmp.dir property does not have a TMP annotation to it. For example, you can configure the dfs.name.dir directly to something like /hadoop/dfs/name, which does not have any dependency on the temp.dir property at all. Or alternatively, you can set the hadoop.tmp.dir property to say /hadoop, which is actually removing the temp annotation to it. But in our example, let us go ahead and continue to set up the property value to /tmp/hadoop. Next, we need to edit another configuration file called hdfs-site.xml, which basically contains configuration information related to the HDFS function of Hadoop. The one important property we update in this file is dfs.replication. This is otherwise called the replication factor and indicates the number of copies of every block that needs to be replicated in HDFS. By default, the replication factor is 3, but since this is a single node Hadoop cluster, we need to explicitly set it to 1. The dfs.name.dir and the dfs.data.dir properties that we discussed previously are actually set in this file. However, for the purpose of our class, the default values work well, so we do not explicitly set this. So let us edit the hdfs-site.xml file. As you can see, I have already updated the dfs.replication property in this file. So let us go ahead and close this. And finally, we need to edit the mapred-site.xml file as well, which basically contains configuration information related to the MapReduce function of Hadoop. So to do that, I type vi space mapred-site.xml. Here we configure the mapred.job.tracker property that basically indicates the host and the port that the MapReduce job tracker runs at. I have already done this and I have set the port to 54311. Let's save and close. With that, we have configured our single node Hadoop cluster. Let us see what is up next. The next step to starting your Hadoop installation is basically formatting the Hadoop file system, which is implemented on top of the local file system of your cluster. You need to do this the first time you set up a Hadoop cluster. Formatting a name node for the first time simply initializes the directory specified by the dfs.name.dir property. To format the file system, navigate to the Hadoop folder and run the below command. bin/hadoop space name node minus format. Once you see this message that it has been successfully formatted, we are now ready to start our Hadoop cluster. Before that, let us quickly check what all processes are currently running on the machine. We can find this out by typing JPS, where JPS basically stands for Java Process Status, and it lists all the Java processes that are running for the current user. So you can see here that the only Java process that is running is JPS itself. So from the same folder, run the below command. So as you can see, it says it's starting the name node, the data node, the secondary name node, job tracker, and finally the task tracker. So what the start-all.sh file did was basically to start all the required Hadoop processes, right? So now let's type JPS and see what are the different processes that are currently running now. So as you can see, you have the name node, you have the secondary name node, as well as the data node running, and you have the job tracker and the task tracker running. So you have all the required Hadoop daemons running successfully now. But just in case any of the process is not running, you can troubleshoot by checking the logs. Hadoop's logs are stored in the logs directory inside Hadoop. This will show you all the log files created by Hadoop, and as you can see, there are log files separately for each of the processes. Search for the log file of the process that is failing. Copy the file name and then type the below command. So let's assume for a minute that you do not have the data node running. So let's check the log file of this file. So what this command does is basically displays the last 40 lines of this particular file, which are basically the latest log entries in that file. So now look for an entry which might indicate an error or warning and then debug accordingly, right? So in our case, we do not have any issues, right? So since all of our processes are running successfully, we have now started our first Hadoop cluster. So congratulations. Wasn't that easy? Now let us quickly check if it is actually working as intended. So to check if HDFS is working fine, let us run a command to list the files inside HDFS. To do that, I'll go to the Hadoop directory, and from there I type the below command. So we are going to find more information about this command in the next couple of videos, but for now just run this command and see if it runs successfully. As you can see, it does return the directory contents of the root directory inside HDFS. So with that, we can verify that Hadoop is indeed working fine. So in cases where you need to stop your Hadoop cluster, you can always run the bin-stop-all.sh command from within the Hadoop directory. But before that, let us check what is actually there in the bin folder of Hadoop, right? As you can see, there are many shell script files. The script files are actually called as control scripts and serve the purpose of running commands and starting and stopping daemons across the whole cluster. There are a couple of files called as masters and slaves, which basically capture the addresses of the master nodes and the slave nodes in the cluster as well. But since this is a single node Hadoop cluster, we are not going to update those files. There are a few other control scripts, and we will look at what they actually do. So we already seen start-all.sh, and then there is stop-all.sh. So running this script file starts or stops all the Hadoop processes, both HDFS and MapReduce. We have start-dfs.sh and then stop-dfs.sh. This starts or stops only the HDFS processes, namely the name node, secondary name node, and the data node. And then you have start-mapred.sh and stop-mapred.sh, which basically starts or stops only the MapReduce processes, which are the job tracker and the task tracker. So that's it. We have come to the end of the videos on setting up a single node Hadoop cluster. So whenever you want to practice, you can just start up the virtual machine and remember to start up Hadoop. So in the next set of videos, we will do some hands-on sessions on HDFS and MapReduce. Thank you for watching.